Hello everyone. In the previous chapter, we discussed the concept of the internal structure of G waves. Now, let's delve deeper into the subject to uncover further insights. When the scholar turns his gaze toward a pair of large breasts, the first thing that appears in his visual field is the image of the breasts. In other words, the visual sensory receptors have already generated a G wave that contains the internal structure characteristic of those breasts. This image appears on the scholar's retina at a specific point, meaning that part of the retina participates in producing the G wave with the characteristic of the breasts. Simultaneously, this internal structure is coupled with special orientation information, providing the scholar with a sense of where the object is located in space. Thus, when the scholar initially generates a visual G wave with the internal structure of the breast, the G wave of chest attraction is activated, which in turn triggers the instinctive G wave association that leads to the scholar's action of glancing sideways. At this point, the side glance follows the special orientation information related to the breasts. But what happens if the woman is running? Let's explore how the positioning of this glance is formed. Since G waves are continuously input, the internal structure and spatial orientation of the breasts are constantly changing. As a result, the activation of the instinctive G wave associations will adjust according to the changes in the G wave. This dynamic process of capturing the image and producing the side glance follows the same basic principle. From the above, we can conclude that a visual G wave consists of a series of internal structures along with the associated spatial orientation information. Since the G wave may be continuous over time, both the internal structures and the spatial orientation information might change, forming a function-like curve that evolves over time. This evolving process, which represents the characteristics of the visual G wave during a certain period, can be projected to activate other G waves in the mind, potentially leading to the two emotions or predictions. Now, someone might ask, what if the woman suddenly disappears while the scholar is performing the side glance? In this case, the scholar's glance will no longer be able to produce a G wave with the internal structure of the breasts. The chest attraction G will no longer be activated by the visual G wave. This situation brings us back to the concept of expectation we discussed earlier. The scholar may feel disappointment, or he might activate a general common sense G or similar situational G wave, leading to a search behavior. The strength of this behavior often depends on how much the expectation G wave was activated by the chest attraction G wave. We've used the example of viral G waves, but the same principle applies to other sensory organs. Behaviors are often continuous rather than instantaneous, meaning they require real-time participation from sensory systems. In fact, complex behaviors are often reliant on the real-time involvement of multiple sensory organs. This highlights an important principle. Complex behaviors require real-time guidance by sensory G waves to be accurately executed. This principle does not contradict the idea that G-wave associations X contribute to behavior, because according to the combinability and multiplicity of G-waves, sensory G-wave can merge with activated G association, resulting in the continuous activation of the combined G wave. Let's take a break from the theory and have a casual conversation about sensory G waves. Not only do G waves guide our behavior, but they also play a crucial role in the construction of our consciousness. This brings us to an ethical question. When does consciousness arise? This can also be phrased as, when do we become ourselves? Or when can a human be called truly human? These questions often arise in philosophical debates, particularly in discussions about human rights and abortion. So when does consciousness emerge? Regardless how we define consciousness, it inevitably involves G waves, their interactions, and their evolution over time. In other words, consciousness can only arise if G waves are first produced. Now you might think, for G waves to emerge, the nervous system must be functional, and there must be sensory G wave input. This is partly true, but also incomplete. Yes, the creation of G waves relies on the functional nervous system, but G waves don't necessarily need sensory input to emerge. They can also be shaped by genetics. Once the fetal nervous system becomes functional, it begins to generate the first G waves, and consciousness begins to form. Some might argue that without sensory input, there can be no perception of the world, and hence no consciousness. However, a lack of sensory input is still a form of input. It's a zero input state. In this state, the fetus perceives nothing, and it doesn't even realize that it isn't perceiving. This represents a chaotic self-awareness. Therefore, once the fetal nervous system begins to function, the earliest form of consciousness is already in existence. If consciousness originates as early as the fetal stage, then should society reconsider the timing of abortion bans? Would it be appropriate to define the point at which life and consciousness emerge in a way that could influence such laws? This chapter explores the mechanics of how G waves influence both behavior and consciousness, dwelling into sensory input, dynamic changes, and ethical implications regarding the origins of consciousness. By understanding these principles, we gain a deeper understanding of human behavior and the development of our conscious selves. Alright, this is all the content today. See you next time. Bye bye.